Okay, the Hinge theorem is an interesting theorem because if you think about how a doorway is, the door is hanging on its opening by these things called hinges. And so what the Hinge theorem does is it tells us that if we have a pair of triangles that have two pair of congruent sides, so in this one, AB, whoopsie, AB is congruent to XY. You see how they have one tick on them? And then AC is congruent to XZ. Well, these included angles between the sides helps to determine the relationship between that third side of one triangle to the third side of the other. And if our angle here that's indicated with this red mark is larger than this angle indicated with this blue arc, then we know that the side that's opposite this red side, side BC, is going to be greater than the side on the other triangle, YZ. And that's what the Hinge theorem tells us. So if we're solving a problem on Hinge theorem, this one's a multiple choice. It reads, which of the following statements must be true? Okay, so what I think we should do before we start looking at the answer choices is we should go through and make sure that the Hinge theorem applies. In order for the Hinge theorem to apply, I have to have this side congruent to a side on the other triangle, and then another side congruent to a side on the other triangle. And then I look at the relationship between the measures of the included angle. This included angle here at A has a box, which means that this has a measure of 90 degrees. And since 90 degrees is greater than this side, this angle measure here of 70 degrees, then we know that the sides opposite them are going to have that same relationship. So SK, we know, is going to be greater than YU, which is opposite the other angle. So now I go over here and I look for my answer. It's not this one. So SK here is greater than YU. Be very careful. You notice that this choice SK is less than YU. You have to make sure that you understand your symbols of inequality. Okay, so what inequality relates to LN and QL? So we're looking for what's the inequality for LN and QO. First thing I'm going to look, since we're talking about Hinge theorem, let's see, this side ML has a measure of 4, and OP has a measure of 4. Then I have MN has a measure of 7, and QP has a measure of 7. So now we're looking at the included angle. This included angle is 125, whereas this other included angle is just 78. So LN is going to have to be greater than QO, because 125 is greater than 78. And part B, we're reasoning through a triangle problem. So we have triangle A, B, C. And they gave us that AB has a measure of 3, BC a measure of 4, CA a measure of 6. And then in another triangle, PQR, PQ has a measure of 3, QR has a measure of 5, and RP has a measure of 6. And what type of indirect reasoning can we use to explain why the measure of angle P is greater than the measure of angle A? Well, first I'd like to check to see and make sure that the Hinge theorem applies. I see that triangle PQR has a side PQ with a measure of 3, as does ABC here, have a measure of 3. And PR has a measure of 6, and AC has a measure of 6. Now, how do we know that angle P here is greater than angle A? Well, we're doing the same thing that we were doing before, but now we're looking at the side length. So this side length of 5 is greater than 4. And 5 is opposite angle P, and 4 is opposite angle A, so we know that P is greater than A. All right, the converse of the Hinge theorem is pretty much what we just did with that one problem. So let's look and try doing an inequality with angle measures. Now remember, before we were saying that the longer side is opposite the bigger angle. Let's look at this problem, for example 6. We're supposed to write an inequality relating to angle measures. So we're looking at angle UST, this angle UST, and VST. We're going to compare them. Now, if we look at our two triangles, we see that we have US, which is congruent in the other triangle, to VS. And then since we have this side that's going down the middle, this shared side would be the same measure for either triangle. So now our included angle up here is this small little piece here, and the included angle on the other triangle is this one here. So I'm going to look opposite this red angle, and I see that I have a measure of 12. Opposite my blue angle here, I have a measure of 14. Well, angle UST is our blue angle. It has a side opposite it that has a 14 measure, and angle VST has a side opposite with the measure of 12. And we know that 14 is greater than 12, so the measure of angle UST has to be greater than the measure of angle VST, using the Hinge theorem. Well, actually, this is the converse of the Hinge theorem. Uh-oh. I can't stop.
You can move that up.
Okay, good. Well, when, not